Hi, I'm Trevor Flanagan. I'm just going to be running through sort of a simplified version of how vaccines work, and I'm going to be talking specifically more about one of the more exciting innovations that's come just in time for the COVID-19 pandemic. So first, I'm going to be talking about adaptive immunity, just to give us like a baseline of how vaccinations work. Adaptive immunity starts with whatever infecting agent it is. In the case of COVID-19 or coronavirus, it's a virus. The virus infects you, you become infected, you get sick. Through the process of getting sick, your immune system will produce antibodies. Antibodies can recognize the infected agent. So the next time that a virus is introduced to your body, the antibodies are already there, presented by B cells, and they recognize the virus, and you don't become infected the second time. The way that vaccines work is instead of having the virus infect you, instead you're infected with a vaccine, which, being presented with the vaccine, should skip right past the part where you end up getting sick, and your body will take the vaccine or take the viral vector and whatever components are in it, and it will develop the same antibodies so that you form your active resistance. There's a few different ways vaccines are traditionally approached. One way is inactivated vaccines, where you just you kill the virus. So, for example, if you were trying to do it for COVID, you take the coronavirus, you would just kill the virus, inject it into, wherever into the bloodstream, and your body would try to make these antibodies to. That's the general principle, to give you the immunity. Attenuated vaccines, almost the same thing. Instead of entirely killing the virus, you just weaken the virus so that it's not going to have such a strong effect on your body. This might make it easier for it to get to where it needs to go. So a dead virus is just going to be floating around the bloodstream. Weakened virus might be more active and doing a little bit of something in your body, so that your immune system is more likely to recognize it and produce those antibodies. Another way, instead of injecting the entire virus, subunit vaccines take a proponent of the virus. So these little bumps on the virus would normally be spike proteins. Spike proteins are the way that the virus signals the cell and basically knocks on the door, asking if it can come in. Subunit vaccines would basically just take these little spike proteins and introduce those to the body so that the body recognizes that and produces the antibodies. Going even simpler than that, and this is what's the new and exciting form of vaccine, is mRNA vaccines, where instead of introducing the spike protein, you introduce the mRNA and different protein factors that would help produce that mRNA into a spike protein. And so your cell takes that mRNA, genetic information, and can produce the spike protein. So instead of having to introduce foreign bodies or like foreign proteins into your system, it's even smaller than that. It's literally just nucleic acids. It's genes. Your body produces the spike protein and says, hey, this isn't supposed to be here, produces the antibody. mRNA vaccines, most notably Pfizer and Moderna, were the first vaccines to pass clinical trials and start being used. And in addition to being the fastest to be developed, mRNA vaccines have also been the most effective. It was 93, or was it 95 and 96% for Pfizer and Moderna when they were still in their testing phase. They've continued to be effective after rolling them out. So that's essentially the presentation. mRNA vaccines have been very effective, but as the virus adapts and then there's different strains of it, you modify the vaccine a little bit. That's sort of the point of boosters. So to reinforce your body's understanding of the coronavirus vaccine, maybe taking a booster shot would help produce a second antibody, or just reinforce, if you haven't seen the virus in a while, just make sure those antibodies are still floating around around so that when if you do get infected with the coronavirus, you won't develop the COVID-19 symptoms that can be deadly. All right, thank you.